Right. Let's say there is a glass vessel. I have drawn it in larger size, but it is not this much larger. Right. Let's say this glass vessel is completely filled with mercury. This glass vessel is completely filled with mercury. Mercury is a metal in the form of a liquid. Right. Let's say this temperature is, initial temperature is 30 degrees Celsius. Let's say I provide heat energy. I provide heat energy. Then temperature of the vessel is increased. Temperature of the vessel is increased. Then what will happen? That's my question. If we heat this, what will happen to the liquid? What will happen to the vessel? That's my question. What do you think? Do not write anything. Don't draw the figure. Just give me your answers. Just talk to me. If you provide heat energy, what's the first thing that will happen? Huh? Okay. So take your time and think. I'll wait until somebody tell any something. It means something is better than nothing. Sometimes your answer may be correct, sometimes your answer may be wrong, but I want an answer.
So the volume will expand.
Volume will be expanded. Volume of the vessel or volume of the liquid or both?
Both.
Yeah, overall temperature of everything will be increased and volume of everything will be increased. Volume of the liquid is increased, volume of the vessel is increased. If the expansion of the liquid is larger, then what will happen? The liquid has a larger expansion. Then what will happen? You have to think and answer because you are not watching television, right? The class may be in the form online, but students are not dead.
It will exert a force on the.
Yeah, it will exert a force on the vessel. Oshadi, unmute the mic and tell me your answer. Right. You must talk to me. You have to tell reasons. Then only I'll start the lesson. You are silent, I'll also silent. Yeah, you have said something now. What are things you have said? When heat energy is provided, temperature of the vessel increased. Temperature of mercury increased. Volume of vessel increased. Volume of mercury increased. Now my question is, if mercury expands more, if it has a larger expansivity, then what will happen? I think you understood the question.
The vessel might rupture.
The vessel, no, vessel
Might.
is open here. As vessel is open, only one end is the bottom. The vessel is in the form of a cylinder. Bottom end is closed. The upper end is open. Then what will happen? Give a try.
It will overflow.
It will overflow. Very good. What's your name, Buddha?
Ponzi.
Yeah, very good. So if liquid expands more than the solid vessel, the liquid will overflow. Right. So please write example. The real volume expansivity of mercury. The real volume expansivity of mercury is the real volume expansivity of mercury is the real volume expansivity of mercury is 2 into 10 to the power minus 4 per degree Celsius. Whether it is per degree Celsius or per Kelvin, no problem. The real coefficient of volume expansivity or real expansivity, real volume expansivity of mercury is 2 into 10 to the power minus 4 per degree Celsius. Full stop. It is completely filled into a glass vessel. It is completely filled into a glass vessel at 30 degree Celsius. At 30 degree Celsius, it is completely filled into a glass vessel at 30 degree Celsius. Full stop. The internal volume of the glass vessel, the internal volume of the glass vessel is exactly 10 cubic centimeter, is exactly 10 cubic centimeter at 30 degree Celsius temperature. The internal volume of the glass vessel is exactly 10 cubic centimeter at 30 degree Celsius temperature. At 30 degree Celsius temperature. Full stop. The volume expansivity of glass, the volume expansivity of glass is 9 into 10 to the power minus 6. The volume expansivity of glass is 9 into 10 to the power minus 6. 9 into 10 to the power minus 6 per degree Celsius. Now somebody unmute the mic and read that description before I give you the questions as Roman number 1, Roman number 2, and Roman number 3. Somebody unmute the mic and read that description for all of us. After that, I'll give you the questions. Yes, dear, anyone?
The real volume expansivity of mercury is 2 into 10 to the power minus 4 degrees Celsius. It is completely filled into a glass vessel at 30 degrees Celsius. The internal volume of glass vessel is exactly 10 cubic centimeter at 30 degrees Celsius temperature. The volume expansivity of the glass is 9 into 10 to the power minus 6 degrees Celsius.
Okay, very good. Roman number 1. Roman number 1. Find the total volume of mercury at 100 degrees Celsius temperature. Find the total volume of mercury at 100 degrees Celsius temperature.
Sir, can you repeat it again?
Yeah, Roman number 1. Find the total volume of mercury at 100 degree Celsius. Okay. Roman number 2. Roman number 2. Calculate the internal volume of the glass vessel at 100 degrees Celsius temperature. Calculate the internal volume of the glass vessel at 100 degrees Celsius temperature. Right. Final question. Find the overflow volume of mercury. Find the overflow volume of mercury. Find the overflow volume of mercury within brackets displaced volume of mercury within brackets displaced volume of mercury at 100 degree Celsius temperature at 100 degree Celsius temperature. Right. What are the 3 questions? Somebody please read.
Find the total volume of mercury at 100 degrees Celsius. Calculate the internal volume of a glass vessel at 100 degrees Celsius. Find the overflow volume of mercury displaced volume of mercury at 100 degrees Celsius temperature.
Right. Are there any new students in the class? Is there any student who joined to the class for the first time? If so, please tell me. Or just send a message to the Zoom chat. Can somebody read the first question again? Someone in the class?
Find the total volume of mercury at 100 degrees Celsius.
Find the total volume of mercury at 100 degree Celsius. Listen dear, it is said that there are new students. So new students should join to the repeat heat classes from tomorrow night at 8. The last 2 weeks I didn't start, but tomorrow I'll start. Saturday night 8 to 11, there will be a repeat class for heat lesson from the very beginning. Everything will be taught from the very beginning, right? If this is your first class, don't worry. Let me help you. To find the change in volume of a liquid, there is an equation. To find the change in volume of a liquid, there is an equation. That equation is this. Volume of a liquid. Look at board. Volume of a liquid at theta degree Celsius temperature can be found by the equation V naught into 1 plus gamma real theta. This is the equation that we want to use. What is the equation here? Volume of a liquid at theta degree Celsius equals V naught into 1 plus a constant called gamma real into theta. Gamma real is said to be the real coefficient of volume expansivity of a liquid. If this is your first day, this is only a constant for you. If this is your first day, this is only a constant, and value of that constant is given in the question. As I remember something, as I remember it is given as 2 into 10 to the power minus 4. And to represent volume of a liquid at theta degree Celsius, we use a symbol V theta. If V theta is the volume of the liquid at theta degree Celsius, what should be V naught? Somebody unmute the mic and tell me what should be V naught.
Ten cubic centimeters.
Very good. It is the volume of the liquid, volume of the liquid at 0 degree Celsius temperature. So even whether you are a new student or previous students, just write this equation. This is the equation that we are going to use. Write it there first. And while you are writing the equation, can somebody read the description before I give Roman number 1? Before I give you the question, Roman number 1, I have given a description. Let me do something like this. Somebody please take a photo and send to WhatsApp groups dear. Someone take a photo and send to the WhatsApp groups dear. That is better. Photo of the question and send to WhatsApp group. Is video clear here? Are you able to see the board clearly? If video is not clear, say just tell me, then I can change the data connection. Network can be changed. Actually, majority should tell me something, because if one or two students say it's not clear, I can't get a decision. If one or two students say it is clear, I can't get a decision. So what do you think about the video quality? What's the video quality that you get? Please send me a message, then I can adjust.
It's clear, sir.
It's clear. What about others?
Yes, sir.
It's clear, but isn't it? Can you please do something like this? Please take a screenshot of the video and send to my WhatsApp, dear. Then I can get an idea. Right. Until you send screenshots, let me consider. So I'm going to apply this equation to mercury. I'm going to apply this equation to mercury. Right. Okay, thank you. I got enough screen. Thank you, dear. All the students had sent me the screenshots. Good. I'm really happy with it. Right. I'm going to apply this equation for mercury at the given two different temperatures. First, I apply this equation at this equation when theta equals 30 degrees. So first is the first time, the first temperature that I have selected 30 degrees. At 30 degrees Celsius temperature, I apply the equation. V theta equals V naught into 1 plus gamma real times theta. V theta is exactly 10 cubic centimeter. I'm not going to change it. I leave V naught as V naught. I'm not going to substitute value of gamma real. I just write 30 here. And I'll mark this as the first equation. And I'm going to apply the same equation when the temperature is 100 degrees Celsius. V theta equals V naught into 1 plus gamma real times theta. V theta, let me take the volume of mercury at 100 degrees Celsius as V2. V naught, I don't know. 1 plus, gamma real is given, but I'm not going to use it. Gamma real is given. The value of gamma real given, but I'm not going to use it. For the theta, I used 100. Let me mark this as the second equation. So I have obtained two equations by using this equation to the mercury for the two temperatures. But please, carefully, you should write only to mercury. Please write this, underline. After that, please apply the two equations, because there are two things: mercury liquid and the solid glass vessel. So I have applied these two equations only to mercury. Indicate it and write it. Please write them quick. Yeah, I checked the screenshots. In some students, the video is very clear, but for some students, video is not clear. I can't understand the reason. For some students, the video is crystal clear. Right. My advice is just keep your device at a low temperature. Use a fan. That's the best thing. And if you can't hear audio clearly, the best thing is using a headphone. Don't buy Apple AirPods, right? No need to buy Apple AirPods. Buy something like this. This is 150 rupees. You can hear my voice properly. How much? 150 rupees. If you buy two, one will be 100. So use something like this. Then you can hear clearly. Don't force your parents to buy Apple AirPods or Samsung Dots or something like that. No need to buy expensive devices. Right? You just want to hear me. You just want to see the board. That's enough. Right. Then, how do we find this V2? I want to erase this part. I want to erase. Therefore, please take a screenshot if you want any more time to write them. I'm going to erase. Can someone give me a method to find V2? V2 is the volume of mercury at 100 degrees Celsius temperature. So what should I do? Somebody please give me a suggestion.
Divide the second equation by the first equation.
Very good. Dividing the second equation by the first equation. The second equation is V2 divided by first equation 10. So V2 is in cubic centimeter, 10 is in cubic centimeter. Cubic centimeter cancelled out. So I don't worry about the units. Second equation, V naught into 1 plus gamma real times theta. Divided by, not theta. Second equation, 30. Now theta is, in the second equation, theta is 100. 100. Divided by V naught into 1 plus gamma real. In the first equation, the temperature is 30. Right. Then we will get V2 divided by 10. V naught cancelled out. 1 plus gamma real times 100 divided by 1 plus gamma real times 30. Right? Can you do the rest? Value of gamma real is given as 2 into 10 to the power minus 4. Can you do the rest and find V2, dear? Please try to do the rest and find V2. Give a try. Who got the answer? Eh? So next step, 10 can be taken this side by cross multiplication. 10 can be taken to this side by cross multiplication. Then V2 equals 10 times 1 plus gamma real. 2 into 10 to the power minus 4. 2 into 10 to the power minus 2 into 100 divided by 1 plus gamma real is 2 into 10 to the power minus 4. This is 30. Theta is 30. Right. So 10 has a unit of cubic centimeter. So V2 will also have the same units. 1 plus 2 into 10 to the power minus 4 into 100. 10 to the power minus 4 into 100. With these two zeros, minus 4 will be minus 2. That's the point. With the two zeros of the 100, minus 4 will be minus 2. Similarly, 1 plus 3 times 2 is 6. Minus 4 will be minus 3 because of this 1 0. 30, I take this 0. Then 10 to the power minus 4 will be 10 to the power minus 3. 3 times 2, 6. Can you understand this maths here? Please check this maths. Please check this maths part there. Tell me whether you are okay with it or not. Okay, right? Then minus 2 means, look at board, 10, 1 plus minus 2 means 2 decimal points, 0 and 2. Can you understand? 1, 2, that's the meaning of minus 2. Divided by 1 plus minus 3, and 0.123. Got it? 3 decimal places. Write this step here. Please write all these steps and just tell me whether you can understand or not. Ten to the power minus 2. Therefore, there should be 2. If this is 10 to the power minus 2, there should be 2 decimal places. 1, 2. 10 to the power minus 3. 3 decimal places. 1, 2, 3. Okay, dear? Okay or not? I did not multiply. I didn't multiply by this thing. Still, I didn't do anything to this thing. I have kept 10 outside from the brackets. I didn't do anything to that thing. Right. After that, look at board. V2 equals 1 plus 0.02. It means 10 into 1.0. 1 plus 0.02 means 1.02 divided by 1 plus 0.006. 1.006. 10 into this is 10.2. 10 multiplied by 1.2 is 10.2. Divided by 1.006. You have to use log table or you have to use a calculator. So unit is cubic centimeter because 10 of unit of 10 is cubic centimeter. So in the examination, you are not allowed to use calculators. You have to use log tables and find. So what is V2 dear? Somebody? If you divide this, you will get 10.139165. It's a big number. You see, it's up to -4. It means we should keep the answer up to 4 decimal places. See, value of gamma. Gamma real is given as 2 into 10 to the power -4 per degree Celsius or per Kelvin, no problem. So as it's into 10 to the power -4, we should keep 4 decimal places. So 10.1391. This is enough. 9, actually it should be 9.2 because 1.6 is there. So let me take this as 9.2. That is the most reasonable answer. Write it there. Right. I think second question asks us to find the volume of the vessel at 100 degrees Celsius. Am I right here? Volume of the solid vessel or glass vessel at 100 degrees Celsius temperature. That's what they have asked. So even to find the volume of a solid vessel, we can use the same equation, right? To find the volume of a vessel, even for a solid object, we can use the same equation. But in the V theta equation for a solid, we don't use gamma real, we just say gamma. Right. So please try it. Let us apply the following equation to find the volume of the glass vessel. Let us apply the following equation to find the volume of the glass vessel. Let us apply the following equation to find the volume of the glass vessel. Right, look at board there. So first thing, at 30 degrees Celsius to the glass vessel, we apply the equation V theta equals V naught into 1 plus gamma theta. Here, we don't use the term real for a solid. The term real is used only for liquids. V theta is the internal volume of the glass vessel at 30 degrees Celsius. It is given as exactly 10 cubic centimeter. The internal volume of the glass vessel is 10 cubic centimeter. Therefore, as the vessel is completely filled with mercury, the volume of mercury is also 10 cubic centimeter. What's the logic here? Volume of the vessel is internal volume of the vessel is 10 cubic centimeter at 30 degrees Celsius temperature. Therefore, as the vessel is completely filled with mercury, the volume of mercury should also be 10 cubic centimeter. That's why we get 10 here. So V naught is the internal volume of the glass vessel at 0 degree Celsius temperature. 1 plus gamma real. Gamma, sorry, not gamma real. Gamma for, I don't worry about this. Gamma value is given. Theta is 3. So let me take this as my third equation, right? So similarly, I apply the same equation at 100 degrees Celsius. What's the equation? V theta equals V naught into 1 plus gamma theta. So volume of the vessel at 100 degrees Celsius, that's what we want to find. We want to find the volume of the vessel at 100 degrees Celsius temperature. So let me take it as V3. V3 is the volume of the vessel at 100 degrees Celsius temperature equals V naught into 1 plus, I don't, the value of gamma is given in the question, you may check. This is 100. So let me mark this as fourth equation. Divide 4 by 3, then you can find V3. V3 is the internal volume of the vessel at 100 degrees Celsius temperature. Complete, dear. Start. In heat questions, do not round off the volume values. Volume values, length values, do not round off. At least keep the answers up to 5 decimal places. At least keep the answer up to 4 decimal places in heat questions in expansion sections. For expansion questions, keep the answers up to at least up to 4 decimal places. Do not round off. Okay, dear. Okay, let's divide. Let's divide the fourth equation by the third equation. The fourth equation tells us V3, third equation 10. Fourth equation, V naught into 1 plus gamma times 100 divided by V naught into 1 plus gamma times 30. So V naught cancelled out. V3 divided by 10 equals 1 plus the value of gamma. Value of gamma of glass is given as 9 into 10 to the power minus 6. 9 into 10 to the power minus 6 and 100 will be there. Divided by 1 plus gamma of glass 9 into 10 to the power minus 6. This is 30. This is 30. So let me take 10 to this side. Then I'll get V3 equals 10 times 1 plus 9 into minus 6 will be minus 4 because of the two zeros of 100. So it will be 10 to the power minus 4 divided by 1 plus 3 times 9, 27. And with this 0 of this 30, minus 6 will be minus 5. Can you understand this, maths? Due to the 0 of the 30, because of this 0, minus 6 will be minus 5. 3 times 9, 27. So like that, you have to simplify. This is what I have asked you to do. Check your simplifications, dear. Please check. Our value of gamma is given in the question. Our value of gamma should be given in the question. Didn't I give you the value of gamma, dear? The volume expansivity of glass is 9 into 10 to the power minus 6. Haven't I given it? Please check. Value of gamma was given in the question. Please check. Right, let's simplify this further. Okay, look at board. So this is the unit of this is 10 is 10 cubic centimeter. 1 plus 10 to the power minus 4. So 0.1234 divided by 1 plus 10 to the power minus 4. 1, 2, 3, 4, 5. Can you understand this, maths? 10 to the power minus 5. So 0.1234, decimal place should be there. 10 to the power minus 4. So 0.1234 decimal places should be there. So this is 10 into 1.0009 divided by 1.00027. So if you multiply by this, 1.0 will be 10.009 divided by 1.0027. So in the examination, you have used a log table and find this value because you cannot use calculators. Do it. If you simplify, you will get the final answer as 10.00629. You will get the answer 10.00629 cubic centimeter. How many decimal places here? 1, 2, 3, 4. Here should also be the same. 1, 2, 3, 4. Fourth one. So last one can be rounded off. The last one can be rounded off. So this may be kept as 3. But here you can't do the rounded off. You can round off at the final decimal point, but there should be at least 1, 2, 3, 4 decimal places. In the place of the fourth decimal place, yeah, it is okay to round off. Complete? Who got this answer? Right. So what will be the overflow volume of mercury? How do we find it? How do you find the overflow volume of mercury? Somebody please give me a method.
Subtract expanded volume of mercury with the expanded volume of the vessel.
Yes, very good. We should subtract, very good, Buddha. We should subtract the volume of the mercury at 100 degrees Celsius, volume of the vessel at 100 degrees Celsius. Am I right here? Part of mercury will be used to fill the vessel, the rest will overflow. Therefore, if someone asks us to find the overflow, overflow volume of mercury. Overflow volume of mercury equals volume of mercury at 100 degrees Celsius. Volume of mercury at 100 degrees Celsius temperature minus volume of the vessel at 100 degrees Celsius. From this equation, we can find the overflow volume of mercury. Volume of mercury at 100 degrees Celsius is V2. Volume of the vessel at 100 degrees Celsius is V3. We know both V2 and V3. Use this equation, find overflow volume. Give a try, dear. Give a try. Find it. Right, if we subtract this, V2 is 10.1392. V3 is 10.0063. 10.0063. If we subtract this, we will get 0.1329. 0.1329 cubic centimeter. Who got this answer? Who got this answer? Gamma value was up to 10 to the power minus 4. Therefore, final answer is kept up to 4 decimal places. So if the value of the fourth decimal place is slightly changed, maybe 1328, 1327, 1320, it's okay. Only the fourth decimal place, changes in fourth decimal place are allowed. Others are not allowed. Right, please write them all. Once you have written all the things that are written on the board, send me a message. Then I'll go to the next theory part. Who wants more time to write the things? May I go to the next section, next theory part? Right. If you want any more time, please take a screenshot. I'm going to erase. I'm going to erase everything that I written on the board. But if you think that you want more time to write, please take a screenshot. Right. Look at board here. I'm going to ask some question. Listen to me carefully and give me answers. Okay. Right. Let's say there is a vessel. The vessel is filled with a mixture of ice and liquid wood. What are things here? Ice plus liquid wood. Somebody please tell me the temperature of this mixture. What should be the temperature of this mixture?
0 degree.
The vessel is kept under 1 atm pressure, normal atmospheric pressure. The vessel has ice pieces and liquid water. So my question is, what is the temperature of this mixture? Somebody in the class?
0 degrees Celsius. Yes.
Nobody knows. You have never
0
heard a
Celsius.
temperature of ice. Ayyo, what a disaster.
Sir, 0 degrees Celsius.
It is 0 degree Celsius. So if we have a mixture of ice and liquid water under the normal atmospheric pressure is said to be 1 into 10 to the power 5 Pascal. If you keep this vessel under 1 into 10 to the power 5 Pascal pressure, the temperature of such a mixture is said to be 0 degrees Celsius. 0 degrees Celsius. Right. Now let's say there is a glass tube. There is a glass tube. Right. The glass tube here, it is covered. Right. This is a uniform. Uniform mean cross section area of the tube is constant. It is not changed. A uniform cross section area. A uniform glass tube. Let's say this is a glass bulb. Some ice pieces are there. Right. This is a glass bulb. Let's say I have kept some mercury in this glass bulb. Right. And I have marked the height of this mercury. Let me mark this height of mercury as H0 centimeter. So this is mercury. Somebody unmute the mic and tell me the temperature of the mercury in the glass bulb. Somebody, what is the temperature of the mercury in the glass
0
bulb?
degrees Celsius.
Sorry?
Yes.
I didn't hear
0
you
degrees
properly.
Celsius.
Try again.
0 degrees Celsius.
It is 0 degree Celsius. Very good. Right. My next question is this. Listen. Listen to me carefully. Let's say there is another vessel. This vessel is filled with boiling water. Boiling water under 1 atm pressure. 1 atm pressure means atmospheric, 1 atmospheric pressure. Somebody unmute the mic and tell me the temperature of this water. Somebody?
Degrees Celsius.
Sorry?
100 degrees Celsius.
100 degree Celsius. It is 100 degree Celsius. Now my next question is, I take this gadget and placed here like this. I take this gadget, the vertical glass cylinder and this glass bulb, I placed it here. Then what is the temperature of mercury in this glass bulb and this vessel cylinder? This is a uniform narrow glass tube. Let's say narrow, uniform narrow glass tube, right? So what is the temperature of mercury in this glass tube? Somebody?
100 degrees Celsius.
100 degrees Celsius. Will the height of mercury column in the glass tube will be greater than H naught or smaller than H naught under this temperature?
Greater.
Greater than H.
Greater than H naught. So when you increase the temperature, mercury will be expanded. So expanded mercury will rise up in the glass tube. Here there is nothing. Nothing is inside the glass tube. Therefore, it is said to be a vacuum. What's the meaning of vacuum here? There is nothing inside the glass tube. That's the meaning of vacuum. So when the temperature is increased, it can be observed that height of the mercury column in the glass tube is increased. Mercury is expanded. So let me mark this the new height as H100. H naught is the initial temperature, initial height. H100 is the height of the mercury column at 100 degrees Celsius. So here we mark the temperature as 0 degree Celsius. Here we mark the temperature as 100 degree Celsius. Right. So what can we do with this gadget here? What is the use of this gadget? Can somebody suggest me a use of this gadget?
Measuring temperature.
It can be used to measure temperatures. So if we divide this gap, if we divide the gap between H naught and 100, if we divide this gap, let me mark this as simple H into 100 equal divisions. If we divide this simple H into 100 equal divisions, one section, one such a division will represent a temperature of 100 degrees Celsius. Clear? But it is not used, it is not necessary to use a mercury as the liquid. If you want, you can use alcohol also as the liquid in a thermometer. So this type of a thermometer is said to be a liquid in glass, a liquid in glass thermometer. So please write the next subheading, a liquid in glass thermometer. Let's write the next subheading as a liquid in glass thermometer. What is the next subheading there? A liquid in glass thermometer. Right. Please wait for a minute. Write the heading as a liquid in glass thermometer. Wait a minute. Right. So we use this method. We use this method to make thermometers. This is a method that is used to make thermometers. Right. So please write the description. A liquid in glass thermometer. A liquid in glass thermometer can be constructed as shown in the following figure. A liquid in glass thermometer can be constructed as shown in the above figures. A liquid in glass thermometer can be constructed as shown in the above figures. As shown in the above figures. Okay, dear. Right. Initially, continue. Initially, the glass bulb is kept in a mixture of ice and liquid water. Initially, the glass bulb is kept in a ice and liquid water mixture. Ice and liquid water mixture. Full stop. The temperature of such a mixture under 1 atm pressure, the temperature of such a mixture kept at under 1 atm pressure is 0 degree Celsius. The temperature of such a mixture kept under 1 atm pressure is 0 degree Celsius. Is 0 degree Celsius. Full stop. The height of the liquid column in the vertical glass tube. The height of the liquid in the vertical glass tube is marked as H0. The height of the liquid column in the vertical glass tube is marked as H0 at 0 degree Celsius temperature. Is marked as H0 at 0 degree Celsius temperature. At 0 degree Celsius temperature.
Sir, can you repeat?
Can somebody read that note up to that point? Somebody in the class, please read it.
A liquid in glass thermometer can be constructed as shown in the above figure. Initially, glass bulb in ice and liquid mixture. The temperature of such a mixture kept under 1 atm pressure is 0 degree Celsius. The height of the liquid column in the vertical glass tube is marked as H0 at 0 degree.
Thank you, dear. Who would like if another student read it? Who wants to hear it again? Here, who would like if we repeat the note again? Anybody in the class? Okay, now another student has a chance. Another student, please read the same note. help others.
A liquid in a glass thermometer can be constructed as shown in the above figures. Initially, the glass bulb is kept in the ice and liquid water mixture. The temperature of such a mixture kept at under 118 pressure is 0 degrees Celsius. The height of the liquid in the vertical glass tube is marked as H0 at 0 degrees Celsius temperature.
Thank you. Anybody wants to hear it again? Any other wants to hear the note again? Listen to the note again. Okay. Somebody please read the note. Sorry, somebody please take a photo of the note and send to the WhatsApp group with the 2 thermometers. That will be a big help for all the students. Take the photo of the figures and the note and send to the WhatsApp group or send to my new WhatsApp number. Then I can share it with the students. Right. Next point. Next point. Next number. After that, please write. After that, the glass bulb is kept in boiling water under 180 atm pressure. After that, the glass bulb is kept in boiling water under 180 atm pressure. After that, the glass bulb is kept in boiling water under 180 atm pressure. Full stop. Then it can be observed that, full stop and continue. After that, the glass bulb is kept in boiling water under 180 atm pressure. Full stop. Then it can be observed that, length of the mercury column in the glass tube is increased, has been increased. Then it can be observed that the length of the liquid column in the glass tube has been increased. Then it can be observed that the length of the liquid column in the glass tube has been increased. The new height of the liquid column, is marked as H100, simple H100. The new height of the liquid column has marked as H100. The new height of the liquid column has marked as H100, simple H100. Right, who would like if we read the note again? Anybody in the class? Somebody please read the note again, that point. Somebody. කොහොමද අපේ ළමයි ඉන්නව නේද? අකීලා ඉන්නවා, අකිල්, ෂෙහාන්, many students are there. Gimhan, Senaratna, Vihara Srimali, Vishwa, Sainab. Somebody please read that point there.
After the glass bulb is kept in boiling water, 1 atmosphere pressure, then it can be observed that length of the liquid column in the glass tube increased. The new height of the liquid column is marked as H100.
Very good. Thank you, Akil. Anybody wants to hear it again? Anybody in the class who wants to hear it again? Right, please try. The length of the glass tube, the length of the glass tube, next slide, next point. The length of the glass tube in between 0 degree Celsius mark, the length of the glass tube in between 0 degree Celsius mark and 100 degree Celsius mark. The length of the glass tube in between 0 degree Celsius mark, in between 0 degree Celsius mark and 100 degree Celsius mark are divided into 100 equal divisions, are divided into 100 equal divisions, are divided into 100 equal divisions. Full stop. Then, full stop, then such a division represents, such a division represents, such a division represents a temperature of 1 degree Celsius. Then such a division represents a temperature of 1 degree Celsius, 1 degree Celsius. Okay, dear. Right. I'll repeat it from the beginning. The length of the, listen to me carefully, I'm repeating. The length of the glass tube between 0 degree Celsius mark and 100 degree Celsius mark. The length of the glass tube between 0 degree Celsius mark and 100 degree Celsius mark are divided into 100 equal divisions, are divided into 100 equal divisions, are divided into 100 equal divisions. Full stop. Then such a division, then such one division represents 1 degree Celsius. Then such one division represents 1 degree Celsius. Right? Who would like if I repeat the note? Who wants me to repeat the note? Anybody in the class? Ashen, put your hand down there. Your hand is always raised up. Right. Then there is a message. So if the length of the glass tube in between 0 degree yeah, let's discuss a numerical question, then only you can understand this concept here. Listen dear, listen. So let me erase these unwanted parts. Once we erase the unwanted sections, you will be able to see the wanted section properly. Once we remove the unwanted things, we'll be able to see the important things. Let me remove them. After that, let's discuss a numerical example. Then you will understand everything. Right. Look at board. So when the temperature is 0 degree Celsius, length of the liquid column. When the temperature is 0 degree Celsius, length of the liquid column is h naught, maybe centimeters or meters. Similarly, when the temperature is increased up to 100 degree Celsius, when the temperature is increased up to 100 degree Celsius, the length of the liquid column in the tube is H100. Now we divide this gap between this 0 degree Celsius line and 100 degree Celsius line into 100 equal divisions. Then one division represents a temperature of 1 degree Celsius. For example, if H naught is 2 centimeter, right? H100 is 52 centimeter. Then what is simple HD? Somebody please tell me what is simple HD?
50 centimeters.
50 centimeter. It should be 50 centimeter. Am I right? So this 50 centimeter gap represents 100 degrees Celsius. Length of the mercury column at 0 degrees Celsius, 2 centimeters, starting from the bulb. Length of the mercury column at 100 degrees Celsius, 52 centimeter. So it means when the temperature increase from 0 to 100, length is increased from 2 centimeter to 52. It means length is increased by 50 centimeters. So a temperature of 100 degrees Celsius represented by a length of 50 centimeters. Therefore, temperature of 1 centimeter represented by, how do we find it there? Sorry, temperature of 1 degree Celsius is represented by how many centimeters there?
0.5.
50 divided by 100. It means 0.5 centimeter. 0.5 centimeter represents a temperature of 1 degree Celsius. The opposite logic. 50 centimeter length represents a temperature of 100 degrees Celsius. Then what is the temperature represented by 1 centimeter? How do you find it?
Fifty divided by
100 divided by 50. Am I right? So it is 2 degrees Celsius. 1 centimeter shows 2 degrees Celsius. 0.5 centimeter shows 1 degree Celsius. Simple. 0.5 centimeter shows 1 degree Celsius. Therefore, 1 centimeter should show 2 degrees Celsius. 0.5 times 2, 1. 1 times 2, 2. Clear or not? Would like if I explain the story again? Right. Now, look at board. Look at board. Let's say the thermometer is here. This is the thermometer bulb. The new temperature is theta degree Celsius. The height of the liquid column, right, from the bulb. Now let's say H theta is 40 centimeter, right? What is the temperature theta? So that's what I am going to ask, right? So please write a liquid in glass thermometer, right? Example, numerical example, a liquid in glass thermometer is constructed as shown in the following figures. A liquid in glass thermometer is constructed as shown in the following figures. As shown in the following figures. Full stop. Find the value of the temperature theta according to the data given in the figures. Find the temperature theta. Find the value of the temperature theta according to the values given in the figures. According to the values given in the figures. Start.
Sir, can you repeat the question, please?
If you want, if you want to repeat, just tell me. If not, draw the three figures. You can use any method. Just tell me what the theta is. But you must draw the three figures. Start.
Sir, can you repeat the question?
I'll repeat the question. Listen carefully. A liquid in glass thermometer is constructed as shown in the following figures. A liquid in glass thermometer is constructed as shown in the following figures. Full stop. Find the temperature theta. Find the temperature theta, comma, according to the data given in the figures. According to the data given in the figures. Right here. Draw the figures and find the temperature theta and send me your answers to Zoom chat. If you have started, if you have obtained the answers, please send me the. I'm waiting for you. I'm waiting for your answers, dear. Send your answers to my Zoom chat or unmute the mic and tell me your answer. What is the temperature theta?
Yeah. 76 degrees Celsius.
76 degrees Celsius. How many students agree with it? How many students agree with that answer? 76 degrees Celsius.
76.9.
36.9. Any other
76.
answers?
Point.
If we have 100 students in a class, there should be at least 75 different answers for temperature theta. That's the nature. But still I got 3-4 answers. Any other answers? So what is the logic? What's the normal thing? If we have 100 students in a class, for the temperature theta, we must have at least 70 different answers. We got another temperature, 76 degree, 76, 66, 65, 39.6. Any other answers? Any other answers? So what's the method there? What are the methods? The length, right? The length which represents 100 degrees Celsius is 50 centimeter, right? Therefore, the length which represents 1 degree Celsius. 50 centimeter represents 100 degree. Therefore, 1 degree represents 50 over 100 centimeter. So it means 0.5 centimeter. 0.5 centimeter represent 1 degree Celsius, right? Therefore, 1 centimeter represents. Therefore, the temperature represented by, therefore, the temperature represented by 1 centimeter length. 0.5 centimeter, 1 degree Celsius. 1 centimeter should be then 2 degree Celsius. Right. Now, what is the length above 0 degree Celsius? This is 40 centimeter. This is 2 centimeter. 2 centimeter length should be there. Therefore, what is the length of the liquid column which is at above the 0 degree Celsius temperature? The next statement should be written here. The length of the liquid column at above the 0 degree Celsius mark. 40 from the neck of the bulb. From 0 degree Celsius, what is the length there? 40 minus 2, that is 38 centimeter. 1 centimeter length above the neck represent 2 degrees Celsius. Therefore, length above 30 centimeter length at above the 0 degree Celsius should represent how many what's the temperature here? How many Celsius?
76 degrees Celsius.
sometimes you may have obtained the answer, sometimes you may not have obtained the answer. So whatever it is, please write these statements there. The length simple h which represent 100 degrees Celsius 50 centimeter. So actually all this 50 centimeter length is at above the 0 degree Celsius line. Do not forget it. Therefore, the length which represent 1 degree Celsius is this. The temperature represented by 1 centimeter length, 0.5 centimeter length represent 1 degree Celsius. Therefore, 1 centimeter, it means 0.5 times 2. 1 centimeter should represent 2 degrees Celsius. So the length of the liquid column at about the 0 degree Celsius mark is 38 centimeter. So therefore, final statement, therefore, the temperature, therefore the temperature theta, if the liquid column, if the length of the liquid column at above the 0 degree Celsius mark is 1 centimeter, it represents 2 degrees Celsius. Now the length at above the 0 degree Celsius mark is 38. Therefore the temperature should be, somebody unmute the mic and tell me here. How do you find the new temperature theta?
To multiply by 40.
Yes. How do you find the new temperature theta?
38 into 2. 38 into 2.
38
Into 2.
into 2. 1 centimeter 2 degrees Celsius. 38 centimeter is 38 into 2. So that is 8 times 2, 16. 3 times 2, 6 plus 1, 7. 76 degrees Celsius. Who got this answer? Whether you have obtained the answer or not, write all the statements that I have written on the board saying a note. Start saying a note and write down all the statements that I have written on the board. Start. Do not miss even a single point. Write them all. Please don't be lazy, because I'm going to edit these statements again. I'm going to edit them again. Did you write them all there? Who wants more time to write these things? Who wants more time to write these things? Anybody in the class? I'll check the messages. Yes, sure. I'll definitely check all of your messages and reply. I want to create this group before next Friday, right? So I'm adding the students one by one, and the tudes, right? We have some problems with the tudes, but I think I'll be able to solve everything very soon, because I don't want to send 21 students tudes to 23 students here. Then they will definitely leave my class. So I have to solve that kind of problems. Can you imagine if I send, if my class admin send tudes of 21 student tudes to 23 students? Can you imagine the situation? Right. May I erase the things that are written on the board here? Who wants more time to write the things? Anybody? Right. Look at board here. Look at board. The first statement that I have written, the length simple h, the length which represents 100 degrees Celsius is actually simple h. Yeah, that height is, this height is h. But how do we obtain this h? H is the gap between 0 degrees Celsius mark and 100 degrees Celsius mark. So length which represents 100 degrees Celsius is simple h. Therefore, the length which represents 1 degree Celsius, how do we find it there? Somebody please tell me. 100 degrees Celsius represented by the height simple h. Then what is the height which represent 1 degree Celsius? Somebody please tell me.
H divided by 100.
H over 100. Simple h divided by 100. Simple h divided by 100 centimeter will represent the 1 degree Celsius. Therefore, the temperature represented by 1 centimeter, how do you find it there? The temperature represented by a length of 1 centimeter, how do you find it? What it should be there? This much of length will represent 1 degree Celsius. Then I think we have to write one more sentence. We have to write one more sentence. Therefore, the temperature represented by h over 100 centimeter length, 1 degree Celsius represented by h over 100 centimeter. Therefore, length of h over 100 centimeter will represent a temperature of, somebody unmute the mic and tell me dear. See,
1 degree Celsius.
yes dear.
1 degree Celsius.
1 degree Celsius. 1 degree Celsius. Now please start your second knot. Start your second knot from here. Wait. Start your second knot from this point. Knot number 2. Start. Write this 1, 2, 3 statements. Start. These statements are very, very important. Start there. Did you write them, dear?
Yes, sir.
Right. Now my next statement is, look at board. After this, the length, sorry, the temperature, can you see the board if I write there? Yes. The temperature represented by a length of 1 centimeter. So what should be this length, dear? What should be this length? Somebody unmute the mic and tell me. The temperature represented by H over 100 centimeter is 1 degree Celsius. So what is the temperature represented by 1 centimeter length? How do we find it? There are math students.
1 divided by H over 100 degrees
Yes,
Celsius.
dear. Again.
1 divided by H over 100 degrees Celsius.
This, very good. If this much centimeter represent 1, then what is the length represent by 1 centimeter? So that is very good. 1 degree Celsius divided by H over 100. Are you okay with this, max, dear? Think, write and think. Would like if I explain it again. This 1 degree Celsius divided by H over 100 case. Would like if I explain it again. Anybody in the class? Bhavanta, is it not clear for you? Bhavanta, is it clear for you or not?
Yes, sir.
Huh? Who would like to explain this 1 degree Celsius divided by H over 100 case? Give a try, dear. Unmute your mic and give a try to explain it. Anybody in the class?
Excuse me, sir.
Yes, dear, give a try.
Excuse me, sir. Sir, will it be easy if we explain? Will it be easy if we represent it as 100 divided by H, because 100 if H equals 100 degrees Celsius, then if we divide it by H, we get the value for 1 centimeter.
Yeah, very good. That's the best way to explain. Listen, dear. Very good. H over 100 length represent 1 degree Celsius. 1 degree Celsius. This much of centimeter. This much of centimeter represent 1 degree Celsius. So if I want to make this into 1 centimeter, I should divide this H over 100 should be divided by H over 100. Then what will happen here? If I divide H over 100 by H over 100, this will be 1 centimeter. So whatever the things that I had done to this side, I should do the same to the other side. That's how this H over 100 come to this side. Okay or not? If we divide H over 100 centimeter length represent 1 degree Celsius. So if I divide H over 100 by another H over 100, it will be 1 centimeter. then 1 centimeter, if we have done something to the left hand side, we should do the same to the right hand side. Therefore, that 1 degree Celsius should also be divided by H over 100. Okay or not? Would like if we explain this H over 100, 1 degree Celsius divided by H over 100 case in another method? Anybody in the class would like to hear? Right. Now we know, very good. I think you got this idea. So whatever you do to one side, you should do the same thing to the other side. So let me put this equation mark here. 1 degree Celsius should be divided by H over 100. So then 1 degree Celsius division becomes multiplication when you get the reciprocal. So the temperature represented by a length of 1 centimeter is 1 into 100 is 100 over simple H degree Celsius. There are many other ways to obtain this relationship. There are many other ways to obtain this. If you think by looking at these three figures, you will find many other ways to obtain this relationship. What is the relationship here? The 1 centimeter length, the temperature represented by 1 centimeter length is H or 100 OH. And that 1 centimeter length should be at above the 0 degree Celsius line. The temperature represented by a length of 1 centimeter marked at above the 0 degree Celsius line. Okay, you should understand this simple H is at above the 0 degree Celsius. So this height, it means this one. This should also be at above the 0 degree Celsius line. So if I mark this as capital H theta, this capital H theta length should be marked from the 0 degree Celsius line. So please mark this capital H theta because we want it next. For the next step, we want. Write them all there. Please write them all. Complete the note number 2. I won't write one more sentence. Before that, please complete this there. Who wants more time to write this sentence here? Because I won't write one more statement. Who wants more time to write this? Anybody in the class? Right. I think you can guess the next statement. The next statement that I am going to write is this. Therefore, the temperature represented by capital H theta length, at above the 0 degree Celsius mark. So what I have written, the temperature represented by H theta length at above 0 degree Celsius. H theta length is at above the 0 degree Celsius line. 1 centimeter represent H over 100. 1 centimeter length represent H over 100 degree Celsius. Therefore, H theta length will represent a temperature of, somebody please unmute the mic and tell me the thing that I should write here.
Hundred
1 centimeter length of the liquid column, which is at above the 0 degree Celsius line. 1 centimeter length of the liquid column at above the 0 degree Celsius line will represent a temperature of H over 100 over H degree Celsius. Now, the length of the liquid column at above the 0 degree Celsius line is capital H theta. So, what is the temperature represented by that liquid column? Somebody?
100 over H multiplied by H theta.
Again, I didn't hear you properly, Puta.
100 over H multiplied by H theta.
Very good. If 1 centimeter represent this much of a temperature, if 1 centimeter represent this much of a temperature, then the temperature represented by H theta is this, the product. Correct or wrong? If 1 centimeter length represent H 100 over H degree Celsius, therefore temperature represented by H theta is the multiply. 1 centimeter this much. Therefore, H theta centimeter is this much. The product. Write it, dear. Write it. Look at board. What is simple H according to this figure here? According to the three figures, 100 is okay, no problem. What is simple H according to three figures here? Simple H is equal to H100 minus this height. Am I right there? This height is H0. If you subtract H0 from H100, you will get simple H. Correct or not? What is simple H dear? Somebody unmute the mic and tell me.
Distance between 100 degrees Celsius and
yes, Nick. If this height, if this gap, if this length is H100, if this length is H0, then what is this gap here? The gap between 100 and 0 should be H100 minus H0. So simple H is H100 minus H0. Check again the figures and tell me what the H theta is. What is H theta here? Give me an expression for H theta by looking at this. H theta is simple H theta minus H0. This height is H0. Am I right? So look at what capital H theta plus simple H0 equals simple H theta. So it means capital H theta means simple H theta minus H0. Correct or not? This figure. Just look at this figure. Just tell me yes or no.
yes, sir.
Yeah. So capital H theta is simple h theta minus simple h naught. So what is the final expression there? What will be the final expression? This can be written something like this: h theta minus h naught divided by h100 minus h naught into 100 degrees Celsius. So you can obtain this kind of equations for thermometers in the heat lesson. For the heat lesson, you can obtain this kind of equations. I just wanted to show you one method of obtaining an equation. Please write them all, and if you have written them all, you can leave the class. That's enough for today. And if you have any further doubts, just wait and ask me.
Thank you, sir. Good night.
Good night, all. See you. Good luck. If you have
Thank you,
doubts,
sir.
just wait and ask me. I'm here until you write all the things.
Thank you, sir. Good night.
Thank you, sir.